My name is Bruce Saratani. I'm a solutions architect for IBM. Been focused around cyber and big data for some 5 to 10 years now, but I've been involved with big data actually for 30 years. It wasn't called big data back then, but looking at large volumes of data with all kinds of information to figure out how to get the most value out of it. And recently IBM has applied that to cyber analytics and cognitive, and we'll talk more about that in the second half of this session. So after 20 years in the Air Force, I joined IBM through a few other stops along the way. And it's great to be back in this business. I've been at IBM for 6 years. And looking at cyber data, it still surprises me how much money it costs for every incident. Millions of dollars, right? This is not probably new to anybody in the industry. But what may be surprising to you is it's hundreds of days before people realize they've had an exfiltration. Hundreds of days before they realize they've actually been attacked and impacted. And to make it worse, it's usually somebody else telling you that you've been attacked. It's WikiLeaks or the news or the New York Times is telling you that, by the way, we found this information online, we're not sure where it came from, and you're reading it as a CEO going, that's my proprietary knowledge. How is that in the New York Times? How did this particular political organization get all this information about my campaign months ago, and we weren't even aware of it, right? That's a problem. And the problem is because cyber attacks are pretty smart, and they're trying to hide themselves, and we don't know what to look for sometimes. SIM tools do a great job of finding out the things that we know about. What about the things that we don't know about? And that's where big data and cognitive come into play. What may also be a surprise, and it was to me when I first found this out a few years ago, is we build these wonderful moats around our castle of data. Did you realize that in 2015 we crossed the threshold? That internal threats, legitimate internal threats, not accidental ones, actually exceeded the external threat. So it's always been actually internal threats, insider threats were greater, but a lot of it was just accidental or bad behavior or mistakes being made. But in 2015, the malicious insiders were 44% of the threat, where the external outsider threats were 40%. That moat doesn't do any good if you're not looking inside. So we have to look at the activity of the people who are using the systems, what the systems are doing to figure out what the issues are and where our greatest risk is at. These are people we trusted. And the problem with trusting people is that you need to verify what they do, right? That trust but verify. So in our infinite wisdom, the industry has created 85 tools and 45 vendors to help you solve this problem, right? That's what I need as a CTO or a CIO. I need 85 tools on my desk or 45 vendors knocking at my door. I don't need that kind of grief as much as I need to solve this problem. I also have a problem with I got tools, but I don't have people to use them. By 2020, we're expected to have over 1 million positions for cybersecurity analysts that are unfilled. So if you have a daughter or a son getting ready to go into college, this is a career path to take, okay? Cyber analysts are in great demand, and they're going to have a great opportunity. There's going to be work in this field for quite some time. The other challenge around cybersecurity is when we get hurt, we don't like other people knowing. And when we tell other people we've been hurt, we don't like telling people how we got hurt. So CEOs are unlikely to tell another company or the industry, we're under attack, and here's the problem, defend yourself. Right? We suffer, we hide it, we protect ourselves. I'm sure you've all heard of different retail organizations that have been hacked, and then 2 years later, they finally get found out because some reporter from some New York magazine or New York newspaper announced, oh, by the way, your credit card information's out there. And it's because this particular retailer got hacked, not last month, but 2 months ago, 9 months ago. Right? And they knew it, but they couldn't share that knowledge because obviously they're concerned about their bottom line. So every other industry or every other company in that same industry is exposed to the same risk without recognizing that their neighbor has been attacked. So we're not willing to share the information. That makes it even more difficult to help defend ourselves. I don't know what the attacks are. And the world, the cybersecurity threat isn't a few people. There are organizations designed to attack you, and they're sharing their knowledge. So when they figure out something's working, they sell that technique to somebody else to modify it and use it again. So not only do you have to defend against one person and their technique, if it works, they're selling it to somebody else and modifying it so it's yet another threat. It's kind of like the cold virus, the flu virus rather. Every year you have to get another vaccine because it changed. It's not the same virus again. And there's a market in selling this industry. So the problem is I can't keep throwing more money and more people. I need tools. I need tools that are effective. They're reducing costs. I can't spend my entire company's budget on security. I have to get better quality results out of it. And I have to know I'm being successful. Worst thing is to spend $500,000 on something and finding out that you're protecting the wrong stuff, right? How do I measure that I'm actually protecting the right things and being successful? Same point is, Bruce, I don't need another tool. Like there's 85 tools out there. I don't need another IBM tool or another vendor tool. I got too many monitors to begin with. What if I told you I'm not giving you a tool, but I'm giving you better results through integration of your tools and our tools and giving you up a heads-up display like a fighter pilot? What you need to know is in front of you, what you need to do about it is in front of you, and you can take action. And I have somebody sitting next to you, some guy, you may have heard of him, Watson, that can help you figure out what to do and where to apply your resources at. Right? So today, I want to make it clear that I'm not suggesting we have solutions that rip and replace what you currently have. The solutions today for security platforms, real-time processing, the SIM tools, et cetera, absolutely needed. That's the first line of defense. That's important, right? You need a security guard at the front door when you walk into a corporate building to make sure you belong here and that you're doing appropriate things, right? That's always necessary. But what if you could take big data analytics and other information and cognitive analytics and apply it to that and recognize when something doesn't seem quite right? Like that picture of that person that walked in the building doesn't quite look right, or that's an outdated card. It's still valid, but there's just too many things that aren't quite right. This person doesn't belong there. So as we identify that kind of additional, not just what I know not to look for, right? The little checkbox kind of things. That cognitive thought and that big data thought is what we want to talk about today. So Dr. Lee's going to come and do the second half of this presentation.
Thank you, Bruce. I hope you're scared, right? If you're not scared, hopefully you'll be lucky, because actually cyber attacks is going to happen to you one way or the other. It will happen, and so I'm not really scaring you. Well, I'm Charles Lee. I'm the CTO for Global Business Services in IBM for cybersecurity and biometrics. I worked in, I got a PhD in physics. Actually, these days, cybersecurity is a cross-discipline. What I found is has a PhD in physics really helped me, right? You know, cybersecurity, network, firewall, and software, and mathematics, everything is getting involved. I found it's really tremendous helping me. I've been working on the identity analytics and working on biometrics, identify people in all different ways, correlate those kind of peoples, and for many, many years. So what I'm going to take you is, instead of scaring you, right, I'm really showing you some concepts. There's ways we may tackle this problem, and there's challenges, and I'm trying to really take us to identify where are the challenges we might have a solution, and at the end of it, I'm going to show you a few IBM's technologies will help you to solve some of your problems. So back 15 years ago, I believe it's 15 years, right? Secretary Donald Rumsfeld, and I think he made statements, must be one of the congressional hearings, right? He talked about the enemies of, so there's knowns, so something you know already, and there's things already you know you do not know. It's important to understand. So you know there's something, it could happen to you, but you don't know what they are. That's what it really means. There's also is something you do not know what you do not know, right? Sometimes we make saying people, right, you know, that guy does not know what he does not know. And so this whole concept is really applied to cybersecurity. And we have actually, you know, last 10 years, most of the technologies and techniques is really focused on rules and looking for signatures of virus and malwares, right? And so it's more of a prevention. You know certain things, you try to prevent it, but you're really always one step behind it. So so you will get attacked regardless, right? You're behind. If it's something important, you'll get attacked. So people move to the next step, right? So there's the malware and virus attacks, they change. They change. So you know something is coming, but you don't know who they are. Who they are. So there's a ways really you can look into it, right? That's so-called, you look at the visibility of attack. So that's really the known of unknowns. I think what's going to challenging is a lot of your adversaries, and they have a PhD as I do, and they probably know more than a lot of people. And they're highly intelligent, they're persistent. And so that's the unknown of unknown. And if you have something critical information and critical infrastructure, you will get attacked. And whether you believe it or not, you will get attacked, right? So, so today's defense in depth, this is pretty much the way we're doing it is so-called defense in depth, right? It's not really solving the problem, right? So we have a new challenge, and quantum computing may shine some light for us. Let's see. It's not that bad, actually. As an individual, so when you do something bad, when you lie and to your friends, whether it's friendly or unfriendly, or lie to your wife, there's always cues. There's always cues you can tell, right? So for cybersecurity, traditionally we focus on the IT sources. We look at the packet. We look at we look at the packet. Where we look at the network. We have these wonderful SIEM tools, right, and the known stuff, and you can look at those kind of information. You know what happened. What's really you're not really looking at is there's a lot of non-traditional sources you might also take advantage of. When there's an attack, there's certain behavior at the system level. And the network, there's certain activities you should conceptually does exist. If you really analyze it, you can find something. There's also right when there's a massive campaigns, that something is not unnoticed, but it cannot be noticed as an individual. If you do it manually, it's not going to happen. By the time you find it, it's past history. All right. So there's a lot of extra sources can be leveraged. Conceptually, that can be done. And so we call them security intelligence, threat intelligence, and persona data of the individual behavior, all of those, right? So those are all good. But as an analyst, you really cannot do it by yourself manually. And there's too much data, and there's not enough time, right? So the cognitive computing techniques can really look at all those data for you and come up with some suggestions what you should do. So that's where cognitive computer can play, right? So I'm scaring you, but I'm also really showing specifically what kind of challenge we might be able to solve, right? Next slide. Oh, I'm sorry, I just used to. So if you look at take one step back, right? Cognitive computing is fundamentally, this applies to many areas. Cybersecurity actually started last few years and trying to leverage the technology. And they are not new. Actually, some of you, or probably all of you know the IBM's Jeopardy. And you also heard the recent news of AlphaGo. And they are extremely successful. It's a combination of many different kind of techniques of cognitive computing to be extremely successful, right? Any one of you know Go, right? It's a very complex game. So with the cognitive computing technology, there's no actually human has been, all the humans has lost to the machine. So you can see, right, the cognitive computing advances to a certain level, and we can look into and solve our problem. So some basic concepts of cognitive computing. One concept is learning, right? So we, as a human, we all learn it from a kid, and really you don't know how to speak, you don't know any words, you learn how to speak. You learn a lot of knowledge, like myself, I got a PhD in physics, right? So they'll learn. Machine has a limited capability, but it can learn certain things really well. And some of you might know it. Biometrics is one of the more successful areas. Facial recognition, these are all machine learning, right? You feed some images, and the machine learns and recognize people. And signature, right? You write something, and the machine reads some of it. The next time, you can recognize people. These are learning concept, right? And so machine also interact with humans. So why it's important? It's really help us to really, it's become efficient, and it's more intuitive. So the examples of machine interacts with humans are the languages, right? So why we not program in English? There's reason behind it, right? So we program with the machine code because machine understand the code. And some of them, when I did my thesis, I programmed in Fortran because it's really good with the floating point. And machine does well, right? But but human has intelligence, so we speak language in a certain way, and machine does not understand it. Cognitive computing helps us to interact with the machine. And the next one is really cognitive augmentation. That's extremely important one. It's extremely important of cognitive computing is, right? Cognitive computing is not going to replace humans. And it's like what happened 20 years ago. People think artificial intelligence is the great thing in the world. But it has a downfall, right? It did not produce the expectation people expected. But augmentation is really asking for is really, technically say, is amplifying the capability with the information. Some successful stories was, you see, the Wall Street trading, the stock trading, right, is one of the examples is really intelligence amplification, augmentation. And also, you see, these days, there's, let's say, the auto assistance. So it's not autonomous, but it helps you assist it. I think these are successful stories with those techniques. So we can apply those in cybersecurity, helping us to deal with unknown unknowns. So with the adversaries, our enemies, right? So they have, we're facing continual new threats, and they have different tradecraft, different techniques to attack, right? So you really cannot use the traditional way, looking for a pattern, looking for a signature. And so you are not able to defend the sophisticated attacks, right? So with the learning, and we augment the human intelligence, and with the machine interact with human, we can effectively adapt technology to really defend the threat. And we're also dealing with, Bruce mentioned about it, there's a massive amount of data. It's not a data does not exist. It does exist. If you have an infinite amount of time with the knowledge, you can analyze it. Whoever work as an analyst know that when you solve a problem, what happens, right? You find something, and you find the queue, go to the next one, you find that that's a dead end, and you come back, start another route. So for some of you are old enough, have read the book, The First Cyber Attack is Cuckoo's Egg. That's an interesting book. I mean, anyone in cybersecurity should read that book. It tells you how sophisticated as an individual, all kind of techniques in order to keep track of attacker. And I forgot the details of the book, but I read it. I was impressed. But it requires enormous of knowledge and skill to track somebody's down. So it's an interesting book. I recommend to read it. That tells you, as an analyst, what kind of effort it takes to do that. So with the quantum computing, it's going to extremely simplify that. And so even come with a recommendation what actions you can take. Oops, sorry. So I showed you the last slides. Beyond the concepts, IBM has made a great strides in cognitive computing. The high-flying technology is Watson, right? Watson has a lot of technologies. Specifically, what I'm showing you here is there are several areas of cybersecurity technologies IBM has been developed. And I will just talk through a few of those. So one of which is we call cognitive cyber defense. That's really looking at the domain names, service data, and also net flow data, and go through learning and looking profile, and help you to defend, right? Help you defend. So that's one area we deploy the cognitive technology for prevention and defense, right? And IBM also leveraged the Watson technology to combine different sources to detect problems and also come the course of action. So that's we call the Watson for cybersecurity. There's some details, specific details with it. So without further elaboration, I suggest you, we have a demo, right? Do we have a demo? So I suggest you go to see a demo. And the most right one is when you have a threat, a lot of times, in particular has a large, massive campaign, there's correlations, you will find it. And including the type of attacks and also the individuals. So we do have a solution. The solution is cyber entity resolution that help you to figure that out. The last one is Bruce is an expert on it. Advanced cyber analytics, that's really the, it's built on the large data platform and to forensic analysis and that's a solution. Bruce has a demo on, and if you have interest, you can go to it. So this is the few areas I'm highlighting it. See the cybersecurity application with the quantum computing, it just, I think, happened the last two or 3 years. And even though quantum computing technology has been very successful in the other areas. And so I encourage you to go to see those demos if you have questions, and we can discuss offline on those details. So, so what, right? As a business owner, so what's important is when you have a cyber, so see when you have a cyber attacks, the attacks itself is not important only if it impacts your business. Bruce mentioned, right, there's a research and study, and it takes days for you to find out. You may not even find out by yourself. So even if you know, with the manual steps and process take you days and weeks to figure it out. And so we got a potential, we got a really good potential, adapt cognitive technology. You can have a course of action in a matter of minutes, right? So I'm not really only just discussing the concept. We did talk the concept, but specifically there are some technologies you might be able to leverage. That's all I have. We have 5 minutes for questions. Cuckoo's egg. Cuckoo's. 布谷鸟. Oh. He wrote it, so I don't remember. I just forgot the details. I read it. That was written probably in 1989. In 1980s. That's the first documented cyber attack and also cost, right? It's very interesting. It's really, I encourage you to read that. If you have specific questions on the IBM technologies, and you can ask Bruce or can see the demo or come to me. And so I really appreciate.
Great. Thanks for